Welcome all of you in this tutorial of logistic regression. Let's see what is logistic regression. Logistic regression is a statistical method for analyzing data sets in which there are one or more independent variables that determine to an outcome. That is outcome nothing but a binary variable. What is binary variable? There is only two possible outcomes like yes or no, success or failure, like this. The goal of logistic regression is to find best fitting model that describes the relationship between binary variable that is dependent variable and independent. Now let's see what is the assumptions for logistic regression. Binary logistic regression requires dependent variables should be binary and ordinal logistic regression requires the dependent variables should be ordinal. Logistic regression requires observations to be independent of each other. That is, our observation that is independent variables should be independent of each other. And logistic regression requires there is a little or no multicollinearity among the independent variables. Logistic regression assumes linearity in between independent variable and log odds. For further discussion, we see what is exactly the log odds. Now, logistic regression typically requires a large sample size. So now let's see what is actual mathematical model of binary logistic regression. The logistic regression gives formula to predict the logistic transformation of probability of binary variable of interest. Here is a formula for logit p. Logit p is actually used to classify the our dependent variable, that is our target variable. What is logit p? Logit p is nothing but log of p upon 1 minus p. Then how p is calculated? That is probability is calculated to classify the target variable. This is the required formula for obtaining the probability of targeted variable to classify. Now let's see. Now we see why we have to go for logistic regression. Why we don't use linear regression line to classify the data, to classify the target variable. Let's see why. Let's see here. It is a fitted regression line, and this is our classified data. Here is the data for a tumor which is malignant, and another is a benign. That is one for malignant and 0 for benign. Then here we see our regression line is fitted. Actually, it is fitted actually well. Here threshold gives the probability. Threshold is this for probability p. When our probability p is, here is a actual formula for probability p. When our probability p is greater than 0.5, then our targeted variable should be classified as 1, that is malignant. When it is less than 0.5, then it is classified as 0, that is benign. But when sometimes in our data there is possibility of an outlier, when there is an outlier, our regression line should be fitted like this. Then there is a problem. Let's see what is the problem. When we try to fit, actually our this red data point should be classified as a 1, but when we try to our map it on regression line, what we see, when we map it in here, then it is less than the threshold value. When we map it here, then we see it is less than threshold value. That's why it is classified as 0. Actually it is misclassified. When we try to apply a regression linear line to classify the data. And again, one more disadvantage of linear regression line to classify the data is like this. When we try to fit a regression line, our regression line fit like this. And when we, let's see here, when we try to map this point on regression line, then it is mapped here, and you should be go out of range of the probability. Probability should be in between 0 to 1. But when we try to map this data point, then it should map here. That's why it should be maybe negative value. It is negative value, that's why it is go out of range. So that's why linear regression line is not used for classification in logistic regression. In logistic regression we use sigmoid curve like this. It is a sigmoid curve to classify the data. Then let's see how logistic regression classify data actually. In logistic regression, our targeted variable should be classified using the probability, as we see our previous discussion, the formula for probability P. When our probability is greater than 0.5, then it is classified as 1, and our probability is less than 0.5, then it is classified as 0. Let's here see y be the probability. It is 0.8, then it is classified as a 1. Now here y is a 0.3. This probability is nothing, it is 0.3. In one y-axis we plot the probability. When our probability is 0.3, then it is classified as 0. In logistic regression work like this. Then see logistic regression use log odds to classify the data points. What is log odds? Let's see what is log odds. Log odds is like this. Log odds is calculated by using our probability P. Let's see how it is calculated. Here let's see an example. When P is greater than 0.5, that is greater than 0.5, that is it is between 0.5 to 1, greater than 0.5. Let's see PB 0.8, and then 1 minus PB 0.2. What is the formula? As we see our previous discussion, what is the formula for odds? Formula for odds is P upon 1 minus P, that is equals to 0.8 by 0.2 is equals to 4. Now we calculate log odds. Log odds equals to, here log odds equals to log 4, which is 1.38, which is greater than 0. Again, when we see P is less than 0.5, less than 0.5, that is it is in between 0 to 0.5. Let's see PB 0.3, then our 1 minus PB 0.7. Odds should be 1 upon 1 minus P equals to 0.3 by 0.7 equals to 0.42. Now log odds can be calculated by using log odds formula, that is log of this odds equals to log of 0.42, which is minus 0.86, that is 0. And when our probability is 0.5, then our log odds is calculated by like this. When P is 0.5, then 1 minus PB also 0.5, then P upon 1 minus P is 1, and log of odds equals to log of P upon 1 minus P equals to 0. Then log odd value at 0.5 is 0, and log of odds value for greater than 0.5 probability is greater than 0, it should be positive, and log of odds value for less than 0.5 probability is negative. That is actually it is classified like this. When it is negative, then it is classified as 0. When it is positive, it is classified as a 1. When we apply log odds, then here on the position of 0.5, here is 0, and when our data point is, our log odds is greater than 0, then it is classified as a 1. Our data point is our log odds is less than 0, then it is classified as a 0. Let's see one example. Here is the example of number of hours of studies and result. That is, here is the example of students. Here is we only use one independent variable, but we use more than one variable also, independent variables. When we use this variable as independent variable, this is a target variable, we calculate P, that is we see the formula for in previous discussion. We have use P. When our P is here is a threshold 0.5. In logistic regression there is a threshold which is 0.5. When our P is greater than 0.5, then it is classified as a 1. When our P is less than 0.5, then it is classified as a 0. And again log odds will be calculated as I told you in previous discussion. When log odds is calculated using probability, then here is 0. When our log odds should be greater than 0, that is positive, then it is classified as a 1. When our log odds is less than 0, then it is classified as a 0. We use logic, nothing but logwords, to classify the data in logistic regression. That's why. First of all, we calculate the probability P, and we apply a logic, that is use logic of P to classify the data actually, and how it works actually. A logistics regression will work like this. So may all of you like this tutorial. So please subscribe us. Thank you all of you.